Hello everyone, my name is Nhan Swan Ao, and my task is Computer Vision and IoT, and I'm doing this for task 1, object detection. So I'll show you my GitHub repo. All of the codes are uploaded in here. So what my task was to implement an object detector which identify the classes of the objects. In object detection, I found various ways to detect objects, like using Haskell, OpenCV, Cascade, and using state-of-the-art architectures like YOLO, RCNN, FasterRCNN, MaxRCNN. In this code, I've used FasterRCNN, and you can detect your image from webcam, video, and images. So for object detection on image, I've used FasterRCNN, exception ResNet v2 acting as a backbone. For video, I've used ResNet 50 v1 acting as a backbone. So this FasterRCNN architecture, and this FasterRCNN is entirely from the TensorFlow hub, and this FasterRCNN is trained on image v4 dataset, and image inception ResNet v2 is trained on ImageNet. So this is the output from the webcam, and this is the original one, and it's the detected one. So let me quickly show you the codes. So as this is not a tutorial, I will not deep dive into the code, but if you want to know, please reach me out. So first thing first, I just import all the required libraries. I have used TensorFlow, TensorFlow Hub, Matplotlib, NumPy, and Pillow library. And this is the pre-processing function for image, and this is the main part of the code to draw the bounding boxes, because if we feed our image to the deep neural network, it returns the coordinate points for the bounding boxes, and I just draw these boxes with OpenCV and Pillow library. And this the FasterRCNN URL, and this is just for downloading sample image to detect, and I just loaded using TensorFlow Hub from this link, and I got the model, and once I got the model, I just put the converted image to this detector model, and it returns such values like detection score, detection boxes, classes, etc. And I just draw, depending on these values, I draw the bounding boxes on the images as an overlay, and I'll show you the results. So this is the process of downloading, and this detection, and this sample one I just downloaded using the wget command line, and this is the maximum boxes I wanted to show. Like if you want to show only 9 boxes, you can just change the value in here, and this is the maximum score. Like if an object is detected, it shows how much the bounding boxes are accurate. Like if you want more than 30%, you can just simply change it to like 0.4, and once we feed the image to our detector, it returns such values like class name, detection boxes, and based on these values, I just draw the bounding boxes and a detection score, class label, entities like umbrella, woman, person. So in this picture, there's woman, person, and there's a building behind, so it just returns everything it predicts. And this for sample image 2. In this year, I tried with 13 maximum boxes and maximum score of 10%, more than 10% accurate, and so it detects it, and this detection from webcam. So in order to capture video from the webcam, I use this function. Capture a picture from webcam. So basically what it does is it uses JavaScript to capture image from Coca-Cola because it's not possible to use OpenCV to capture image. It can only be used only JavaScript functions, and once I run the code, it shows it's okay. This shows, and now once I click it, it saves it. Okay, right now it's currently saving, and it's saving as me.jpg, and I just protect the me.jpg in here. Okay, so this is the previous one, and you can detect glasses, human face, man, this is my clothing, but you can't really detect the cup because maybe the dataset wasn't trained on the cup label. So this is for images and from webcam, and so this is for object detection on live webcam and video. I've used FasterRCNN and ResNet 50v1 as a backbone, and it's trained on ImageNet dataset and fine-tuned FasterRCNN on Coco 2017 dataset. This is already a pre-trained model. I didn't train it, I just took it from TensorFlow Hub, and in this code you can detect object detection on your saved video or live webcam, both in Google Colab and Anaconda environment. This is the results on the saved video, and this is the result from live webcam, and both are a bit sluggish and quite slow. So let me quickly show you the code here. So this ResNet 50 architecture, I just import the required libraries. In here I use TensorFlow object detection API to draw bounding boxes, and this is the installation command line. You can see the full documentation in here, and this if it shows okay, then we are good to go. And I just import some utility functions from object detections to draw bounding boxes. And I download the model from this link, which is TensorFlow model, and have download, and it's already done it. And in here this is for capturing video from webcam and save it. So you can capture video without JavaScript in Colab. I have used a bit of JavaScript here, and this saves the video as upload.avi. And let me quickly run this code. So once I click start recording, it records and stop recording, and it upload the video as upload.avi, and you can also play it in here, which is really cool. Okay, and I'm going to use this video to detect objects, and this is the detector function, main function, and in here we run inference on video. If live cam is set to true, it inference from live cam, and if it is set to false, it run inference on the saved video, which is upload.avi. And this code is for inference the video in Anaconda. So what it does is it take frames from the video and feed each frame into the model, and the model returns these values like detection boxes, detection classes, detection score, as I have shown you before. And I just draw the boxes on the frame and show it in the video, and save the whole video as detected upload.avi. And this running. Okay, this is the part, and this is inference on the saved video. The longer the video, the longer it takes the model to inference on the video and detect it. It took me a lot of really time. So once I got the detected upload.avi, I once again use JavaScript to play the video, and okay, this is the detect the video. So it can detect my mobile phone and my glass and detecting me as a person. And what I'm showing you next is running inference on live webcam in Colab. So once again, I'm using JavaScript function, same as before. And let me show you the JavaScript functions right here. Just converting the data types in order to show in the JavaScript object. Okay, let me run this. Okay, it start capturing, and after a few seconds it's going to drop only boxes. Yeah, it takes a bit long time and quite sluggish and very slow. So yeah, once I click it here, it stops the video. Okay, and the other let me show you the inference on live webcam in Anaconda environment. And so I'm gonna move to Jupyter Notebook of Anaconda environment. And what this function does is, right now we are using OpenCV to capture video and show the frames, not JavaScript anymore, because Anaconda supports OpenCV and OpenCV video capture function. And so yeah, in here, and I'm gonna run this, and it shows like this. The video is a bit sluggish, very slow, but it still detects the objects. And that's for all. And if you have questions, feel free to ask me.